Hello and welcome to Math Lessons with Linda. Today's topic is the law of cosines. We have already discussed the law of sines, which is a formula that allows us to solve a triangle for all of the angles and sides when it is not a right triangle. And now we are going to use the law of cosines, which also helps us to solve triangles that are not right triangles. And we would use this if we have a different set of information. So I've written out, first of all, what one of the general forms is for the law of cosines. And that is a squared is equal to b squared plus c squared minus a very long product of 2 times b times c times the cosine of a. So I know this looks like a really long formula, but there's a couple things that you can do to help yourself remember this. First of all is that the beginning part kind of looks like the Pythagorean theorem. It is not, but it gives that vibe, and so that's an easy way to remember it. The second thing is that the first variable, the a in this case, needs to match up with the same variable for the angle of that. So side A is at the beginning, angle A is at the end. Now, the in-between part here, this 2BC, we're always going to have a 2 coefficient, but the BC, these two variables will always be the same as the variables that are squared directly in front of it. Now, there are different forms of this depending on what angle or side you're solving for. So if I change my leading variable to side B and square it, that means this now becomes a squared and c squared. Those are my two squareds. This becomes 2ac, and then I have cosine B. So the first and the last match up. My squareds are the same variables that are in the middle with the 2ac. And if I change it to c squared, it's a squared and b squared go here. Then it's 2ab, and then it's cosine of c. So first and last are the same. These two are the same here. You will only use one of these for your problem. You will not need to use all of them each time. So when do we use the law of cosines? There are two instances where you can use the law of cosines. If you are given all three sides of a triangle, you can plug in all of those values and then just solve for the angle. The other time that you can use that is if you have two sides and you have the included angle between them. So for this, it may be useful to draw a diagram when you're doing it and label everything to determine whether or not the law of cosines would be an appropriate formula for you to use for your problem. So I'm going to get rid of a little bit of this. I'm going to leave our original formula, and I am going to draw a diagram for you. So here is our triangle. And I'm going to label it. Here's my A, B, C. Those are my angles. And this side, which I'm going to have as 30, this side as 21. And my angle A is going to be 123. So if this is angle A, then this is side A over here. And this 21 is opposite B, so like the 21 is really my B, and the 30 is opposite the C, so the 30 is really my side C. So the first thing that I'm going to check is whether or not the law of cosines is appropriate. I do have an angle included in between two sides, and that was one of the times that I'm allowed to use the law of cosines. Since I want to find this side A, the formula that we have right here is appropriate for that. So let's start substituting in what we know. I'm solving for my A squared. So my B squared will give me 21 squared. My C squared is 30 squared. Then I have minus. All this is multiplied together. 2 times 21 times 30. And now the cosine of 123. This is all one term because I have many factors being multiplied together. So I tend to bunch this together so that I don't make an order of operations mistake. The other thing I do is I bunch these together, I square them and add them together. So if we separately, I'm going to show this step right here. This is the 441 from 21 squared, 30 squared is 900. When I do this entire problem, I get 686.24. So this comes directly from here. So now what I'm going to do is I'm going to add these together, subtract this. So my a squared is 2027.24. To solve this, I'm just going to take the square root of both sides. So a would be approximately 45. I think we'll round to the nearest integer because our given values here were for the were integer values. So over here, side A is 45, and I have found that one missing side that I wanted. I am not going to complete this, but we can go back and solve for these other two angles if we choose, and guess what? Now we would just use the law of sines to solve for those, which we've already covered in a previous video. So here's one example of how you can solve a triangle for a side or an angle using the law of cosines.